So we've got this question here. We want to find out the value of this integral. And it's 1 over cosine of x with regards to x. And the parameters are pi over 6 to pi over 3. Now, as this is a reciprocal of a trig function, first of all, we need to establish, is it continuous? Now, we know that cosine of x, when x is pi over 2, cosine of pi over 2 is 0. So this is going to be non-continuous at pi over 2. So as this doesn't fall in that parameter there, we know pi over 6 to pi over 3, this is going to be continuous. So we're clear straight away to go into integrating this thing. Now, the next thing we know is 1 over cosine of x is secant of x. So those two are equivalent. Now, we're not going to be able to just integrate cosine of x because I'll end up with some sine function, and then that's not going to work here because it's a reciprocal. So we need to do some sort of u substitution. So secant x. Why don't we take the derivative of secant x and see what we get? Because when we do a u sub, we're going to have to take the derivative of that u substitution. So let's see what happens. So let's take the derivative of 1 over cosine x. Now this derivative here, we can just plug straight in to our reciprocal rule for derivatives. So then what we do is we square the bottom term. So cosine squared of x. And then we put a minus in front. And then what we do is we now, using the chain rule, we take the derivative of cosine of x and stick that into the numerator. So in the numerator, we now put minus sine of x. So that's our derivative. Now there's a few bits we can do here to clean this up a little bit and make things a little bit clearer. So now we've got two negatives, obviously they make a plus. So now we've got a sine x. And what we could do is now we could split this denominator into two cosines. So now we've got cosine of x, cosine of x. So splitting this up, we could do times 1 on the top. So now we've got tangent here multiplied by 1 over cosine, which we know is secant. It's equivalent to tangent x multiplied by our secant x, 1 over cosine x. And that's still the same in all three lines. But if we substitute u equals tangent x secant x, that's not really going to work for us with our cosine x on the bottom. We need a cosine x on its own. So what we can do is, instead of plugging in that, we could add the two terms together and see where that goes, because then we'll get two derivatives. So we'll let u equal tangent x plus secant x. And while we're here, we can take the derivative of these functions. So our du, well, derivative of tangent x is a famous one, especially when integrating. It's secant squared x. And secant x, we've just integrated, we've just taken the derivative of that here. So we can just plug that in. So now we've got plus tan x secant x. So that gives us some stuff to work with. And then don't forget the dx on the back of that. Okay, that's great. So now what we can do is we can maybe try doing our u substitution with this tan x secant x, plugging that in there. It's not really going to give us anything to go on just yet. So what we can do is, if I plug in, before I do my u sub, tan x plus secant x, and then divide it by the same again, that'll be a nice little trick, which is hopefully going to give us some cancellations. And we know that this is equal to 1. So if I multiply this by this, I'm not going to be changing my integrand at all. So first things first, let's plug that in and see what happens. So we're still in the x world, we haven't gone into the u world just yet. So my cosine of x is my secant of x, so we can go straight into that. So I'll put the brackets round. So now I'm going to put this on my numerator. And then divide that all again by the same function in my denominator. And don't forget the dx. So now I've still not changed my integrand, although it's looking a lot more intimidating. So now we need to get ourselves ready to move into the u world. So what I'm going to do is I'm going to put my u sub in there, find my du from this, and then I'm going to find my u values for all of these. So I'm going to just tidy this up a little bit, and I'm going to find my u values. Okay, now let's get ready to get into the u world. So I've got what my u is. My du is this, not forgetting my dx. And now what I need to do is find out what my dx is. So my dx is just normal algebra. Just divide both sides by this. That'll give me my dx. So now my dx is du over this trig term. So now what I'm going to do is I'm going to factor out a secant x because I've got one in both. And that's going to help me out because I see this term here looks the equivalent of this term here. So that's giving me a clue as what I might be able to do with my cancellations. So I'll factor out a secant x. So now I've got secant x again. And the secant x is already here, so I just add tan x. So that's my equivalent dx. So that there is looking very good when I plug in my du. Now, instead of plugging in my result of my integral at the end and then calculating the values, I like to find what my u values are when x is pi over 3 and x is pi over 6. So let's go through that. So if x equals pi over 3, that means my u, which is tangent x, I've got tangent pi over 3 plus secant pi over 3. So these are all famous values, so we can get these pretty straightforward. Tangent of pi over 3, we know is square root of 3. And secant of pi over 3, we know that this is 1 over cosine pi over 3. So just put that here. 1 over cosine pi over 3. So that is also the equivalent of 1 over a half. So 1 over a half, that's going to give me just 2. So therefore my secant pi over 3 is root 3 plus 2. Okay, that's great for my x equals pi over 3. Now what about pi over 6? So plugging in pi over 6 into my u, that gives me u equals tangent of pi over 6 plus secant pi over 6. So we go through the method the same as we did here. Tangent pi over 6, we know that's a famous one on the unit circle. That is the reciprocal of square root of 3. And secant pi over 6, so as we did here, 1 over cosine pi over 6. So that is going to be 1 over square root of 3 over 2. So taking the reciprocal of that, we just put the 2 on top, and that's going to give me 1 over root 3 plus 2 over root 3. Okay, great stuff. So now let's put these over here nice and neatly, and then we'll try getting into the u world. Okay. Okay. Let's go into the u world with all of this integral here, and let's see what we can get. So at pi over 3, our x transfers our u to root 3 plus 2. So now I'm going to write here u equals square root of 3 plus 2. And now here, when x is pi over 6, we've got 1 over 3 plus 2 over root 3. So that just equates to 3 over root 3. So I'm going to write that there. So u equals 3 over root 3. Okay, now I'm going to write that in because I'm hoping some stuff is going to cancel out here. So secant x times tangent x plus secant x. And then we've got tangent x plus secant x in our denominator. And then my du, which will become my dx, sorry, my du from my dx. This is my dx. So that is the same as du. And then I've got secant x times this function here. So I've got secant x times secant x plus tangent x. Let's see if I can fit that in. I think we'll just get it in just like that. Okay, so now what we're going to do now. Well, this is not going to cancel with anything, but tangent x plus secant x, that's what we want it to be our u. So this will cancel out and become u. And this one is the same as this one and this one. And these will all cancel out. So now my integral now just looks like 1 over u. So let's take the integral of that and see where we go. So now we've got u equals square root of 3 plus 2. U equals 3 over root 3. And then we've just got 1 over u. So after all of that, we just end up with a really handy integral 1 over u du. And we know what that is. That's the natural logarithm of u. So now let's put our answer here. So our answer is natural log of u. Now, as we're dealing with trig functions, we need to just stick an absolute value in there just in case we get any negative values. So that will take care of that. And then what we do is we evaluate that over these u values. So now we've got root 3 plus 2 over 3 over root 3. So that's our two values. We need to try and evaluate this. Now, as these values here are all positive and above 1, we know that that's going to render this absolute value as not required anymore. So we can now drop the absolute value. We put it in there just to make sure, but now we've got these positive values. So we can go straight ahead. So first of all, take this one, natural log square root of 3 plus 2, and subtract from that this natural log. So now we've got natural log of 3 over root 3. Okay, so now we can plug this into our calculator and we can get an approximate value. Let's give to 5 decimal places. That will give you 0.76765, 5 decimal places. And that will give us the answer